Monochromatic light lambda means wavelength is having 600 nanometer is used in YDSE. One of the slits is covered by the transparent sheets of thickness 1.8 into 10 to the power minus 5 meter made of materials having refractive index 1.6. How many fringes will shift due to the introduction of the sheet? So this is the case in case of that monochromatic in YDSE. Here S1, S2 slits are there like that. According to the question, a transparent sheet is introduced in between the source and the screen. Then the question is that how many fringes will shift due to the introduction of the sheet. Here we know when the light travels through a sheet of thickness T, the optical path is going to change with the mu into T. That we know, where mu is the refractive index. When one of the slit is covered with a sheet, transparent sheet, then what happens? Air is replaced by the sheet. Hence the optical distance, optical path changes in this case will be mu minus 1 into T. Here the air is also there and your sheet is also there. That's why optical path changes is equal to mu minus 1 into T. So one fringe shifts when optical path changes by one wavelength. Thus, here the number of fringes shifted कितना कैसे निकालेंगे? By the introduction of sheet, that is equal to mu minus 1 into T by lambda. That should be the number of fringes shifted. One fringe shift when the optical path changes by 1 lambda. So therefore number of fringes shifted will be mu minus 1 into T by lambda. So we have to find out its a value. Put the value and get the answer. Value is 1.6 minus 1 into 1.8 into 10 to the power minus 5. That's all the things are given, and lambda is your 600. Here lambda is 600 nanometer, 10 to the power minus 9 meter. So if you are going to calculate, you will get 18. That should be your answer. Another question, interesting question. A long narrow horizontal slit is placed 1 millimeter above the horizontal plane mirror. The interference pattern between the light coming directly from the slit and then after reflection is seen on the screen 1 meter away from the slit. Find the fringe width if the light used has a wavelength of 700 nanometer. That is the question. So how we are going to solve it? Here it is the things given, whether D is equal to 1 millimeter. D means the like that, the slit, the plane of slit and the screen. That is a D. 1 millimeter, and the things given lambda is equal to 700 nanometer means 700 into 10 to the power minus 9 meter, and the slit width, that is A or B, you can write, no problem, is a 2 millimeter, and the distance between the slit becomes twice of A, that is your 2 millimeter. 2 into 2 distance is given. Here in fact D is given 1 millimeter, lambda is this, and here 1 millimeter is the 1 millimeter given, so the d 1 2 into 1, that is a 2 millimeter. So we have to find out the only fringe width, that is the beta is equal to lambda capital D by small d. So put the value 700 into 10 to the power minus 9 into 1 by d is your 2 millimeter, means 2 into 10 to the power minus 3. How it comes? 2 millimeter, 1 millimeter plus 1 millimeter, 1 millimeter and 1 millimeter. That is your D. So just you find out the value and you will get the value that is around 0.35 in terms of millimeter. That should be your answer. In the same question, here the long narrow horizontal slit is placed 1 millimeter above the horizontal plane mirror. The intersection pattern is between the light coming from directly from the slit and that of the after reflection is seen on the screen. In the same question, one more question is there. Consider the same situation. If the mirror reflects only 64% of the light energy falling on it, what will be the ratio of the maximum to the minimum intensity in the interference pattern observed on screen? अगर 64% केवल लाइट एनर्जी रिफ्लेक्ट हो रहा है मिरर के द्वारा, लॉयड एक्सपेरिमेंट है ये, and then what happens, we have to find out the I1 by I2 ratio of the intensities maximum to the minima. So here it is given I1 by I2 only 0.64, means 64%, 64 by 100, that will be 64 को हम लोग ऐसा लिख सकते हैं 64 by 100, that will be 16 by 25, ऐसा लिख सकते हैं, राइट. सो आई मैक्स, अब यहाँ पर ये हो गया आई मैक्स और आई मिन निकालने के लिए हमको जानते हैं ये क्या होता है, जो एम्पलीट्यूड है उसका रेशियो के स्क्वायर का, एम्पलीट्यूड 1 प्लस सेकेंड एम्पलीट्यूड ऐसे ए प्लस बी होल स्क्वायर बाई ए माइनस बी होल स्क्वायर. तो यहाँ पर हमको एम्पलीट्यूड मालूम करना होगा या इंटेंसिटी दिया हुआ है इस रेशियो में, तो ये निकालने के लिए हम क्या करना होगा, इसमें ए और बी का वैल्यू निकालना. ए बी क्या है, इंडिविजुअल वेव का एम्पलीट्यूड, और एक रिलेशन हमको मालूम है I1 बाई I2 इज डायरेक्टली प्रोपोर्शनल होता है A1 स्क्वायर ए स्क्वायर बाई बी स्क्वायर के. एम्पलीट्यूड कहाँ से आया, I इज डायरेक्टली प्रोपोर्शनल टू स्क्वायर ऑफ द एम्पलीट्यूड. सो प्रोपोर्शनल साइन रिमूव करेंगे तो के कैंसिल हो जाएगा. I1 बाई I2 इज इक्वल टू दिस. सो ए बाई बी निकालना है तो हम क्या करेंगे, I1 बाई I2 का अंडर रूट, दैट इज 16 बाई 25 मीन्स 4 बाई 5, 4 बाई 5 आ गया. अब यहाँ से हम लोग ए इज इक्वल टू 4 ले लेंगे और B हो गया 5, तो B हो गया 5. अब ये दोनों अगर ले लिए, अब हमको निकालना क्या है, अब यहाँ पर यही दोनों का वैल्यू वी हैव टू पुट इट इन दिस. सो I max बाई I min क्या हो जाएगा, A प्लस बी होल स्क्वायर, 4 प्लस 5 स्क्वायर मीन्स 81 एंड A माइनस बी होल स्क्वायर. तो हम स्क्वायर कर रहे हैं तो ये 1 हो गया, 1 का स्क्वायर माइनस 1 का स्क्वायर हो गया 1, दैट 81 इज टू 1. दैट शुड बी योर आंसर, राइट. Only 64% is going to reflect. That is the question.